Okay, in previous video we seen Taylor series expansion, Laurent series expansion. Okay, now we are going to do the problem in Laurent series expansion. Before we enter into the problem, we have to see some basic binomial expansion. Okay, suppose I have a function 1 by 1 minus x. I can give a series representation as 1 plus x square plus x cube if modulus of x is less than 1. The condition exists, I can give the series representation for the function 1 by 1 minus x. Similarly, I can write 1 by 1 plus x equal to 1 minus x plus x square minus x cube and etc. if modulus of x is less than 1. The condition exists, I can give the series representation. You can assume this is the two formulas. When we apply the formula, the condition exists, I can apply the formula. Okay. Similarly, these two, 1 by 1 minus x whole square is equal to 1 plus 2x plus 3x square plus 4x cube plus etc. if modulus of x is less than 1. Similarly, 1 by 1 plus x whole square equal to 1 minus 2x plus 3x square minus 4x cube plus etc. if modulus of x is less than 1. In general, I can write 1 by 1 minus something is equal to 1 plus something square plus etc. if modulus of something is less than 1. This condition exists, I can apply the formula. Similarly, 1 by 1 plus something equal to 1 minus something plus something square minus something whole cube plus etc. if modulus of something less than 1. Okay, now I can consider the function 1 by 2 plus z. I have to use any one of the above formula. For that, I need the structure either 1 by 1 minus x or 1 by 1 plus x, or 1 by 1 minus something or 1 by 1 plus something. For that, there are two possible. One is I can take out 2 outside. If I take out 2 outside, it become 1 by 2, 1 divided by 1 plus z by 2. If I take the other possible, if I take out z outside, I will get 1 by z is outside. The remaining is 1 by 1 plus 2 by z. Okay. Suppose I want to expand this, I need the condition modulus of z by 2 less than 1. So if suppose I have modulus of z by 2 less than 1, then I can give the series representation for this function. That is 1 minus z by 2 plus z by 2 whole square minus z by 2 whole cube plus etc. Similarly, suppose I want to give the series representation of this function. Okay, for this function, I need the condition modulus of z by 2 less than 1. That is, suppose I have the condition 2 by z, modulus of 2 by z less than 1, then I can give the series representation. Okay. So that means in our problem, originally in our problem, we have the condition. By using the condition, we have to conclude that which one I have to take it out. When you observe this, my condition is z by 2. For applying this condition, from this expression, I have to take out 2 outside. Okay. Similarly, suppose I have this condition 2 by z less than 1. For applying this condition, I have to take out z outside from this expression. Okay. If I take out z outside, then only I will get 2 by z. Okay. So for applying this condition, see the denominator, that one you have to take it out. If I have modulus of z by 2 less than 1, I have to take out 2 outside. Suppose I have the condition modulus of z 2 by z less than 1, so I have to take out z outside. Here I miss 1 by 2, okay, because 1 by 2 is outside. I can write 1 by 2 into. Okay, similarly 1 by 2 into. Okay, next we can see the problem in Laurent series expansion. Okay, next we see the problem. This is the most important problem in university point of view. Find the Laurent series expansion of f of z equal to z square minus 1 divided by z square plus 5z plus 6. Valid in the region. The first one is modulus of z less than 2. The second one 2 less than modulus of z less than 3. The third one is modulus of z greater than 3. Okay. So when you find the Laurent series expansion, there are two stages. The first stage is I have to find the partial fraction for the given function. That is the first stage. The stage 2, I have to apply the binomial series. Expansion. What we see in the previous, just before, we see 4 series representation. Okay, or 4 series binomial expansion. So I have to use one of the formula. The stage 1 is I have to apply the partial fraction. Stage 2, I have to apply the formulas 1 by 1 minus x or 1 by 1 plus x. or 1 by 1 minus something, or 1 by 1 plus something. Okay. The stage 1 I have to convert into, I have to apply the partial fraction for the given one. Okay. First find the partial fraction. So z square minus 1 divided by z square plus 5z plus 6. Before finding the partial fraction, try to factorize the denominator. If it is possible, then factorize. So z square minus 1 divided by z plus 3 into z plus 2. Because when you multiply two numbers, it becomes 6. When you add those two numbers, it becomes 5. What are the number? 3 2. 3 2s are 6. 3 plus 2, 5. Okay. Now I have to apply the partial fraction for this one. Okay. So z square minus 1 by z plus 3 into z plus 2. So suddenly you may think that a by z plus 3 plus b by z plus 2. That is wrong. So first you have to observe the degree of numerator and degree of denominator. If it is degree of numerator less than the degree of denominator, then whatever you write, that is correct. That is a by z plus 3, b by z plus 2. But here the degree of numerator is equal to degree of denominator. In that case, you have to apply a special partial fraction. That means I have to include single alphabet then as usual. So b by z plus 3 plus c by z plus 2. Okay. This is 1, this is 2. Now I have to find the ABC. So once again repeat, the degree of numerator equal to degree of denominators. First I have to include single alphabet, then normal procedure b by z plus 3 plus c by z plus 2. Okay. So what's the next step? Just I have to multiply it by z plus 3 into z plus 2 on both sides. Okay. So what do you get? If you multiply this in the left hand side, both will be cancelled. Finally, in the left hand side, I have z square minus 1. Right hand side, a into z plus 3 into z plus 2. Then plus b into z plus 2 plus c into z plus 3. Is it correct? Equation number 3. Now I have to find the unknown a, b, c. So first I can put z equal to minus 2 in 3. In left hand side, what do you get? Minus 2 whole square, it's become 4. 4 minus 1 become 3. In the right hand side, left hand side, if we substitute z equal to minus 2 in the left hand side, minus 2 whole square 4, 4 minus 1 is 3. In the right hand side, this becomes 0, this is 0, only we will get c value. C into minus 2 plus 3. So minus 2 plus 3 is 1, 1 into c is c, final value is c equal to 3. Next, I have to put z equal to minus 3 in equation 3. If you put minus 3, if you put z equal to minus 3 in left hand side, what do you get? Minus 3 whole square 9, 9 minus 1 is 8. This will be cancelled, this will be cancelled, only I will get b value, minus 3 plus 2. Minus 3 plus 2 means minus 1, so minus b is 8, therefore b is minus 8. The next one, I can give another value 0, I can able to find a value. Otherwise, equating the coefficient of highest power of z in the right hand side. What is the highest power of z? Here power of z is 1, here 1, here 2. So I have to equating the coefficient of z square on both sides. Okay, in left hand side, the coefficient of z square is 1. Right hand side, the coefficient of z is only a, because z is z square, the coefficient of z square only a. Here there is no z square, here there is no z square, so directly I can get a is 1. So finally, so our 2 becomes, 2 implies z square minus 1 divided by z plus 3 into z plus 2. The answer is 1. What is 8? Minus 8. So minus 8 divided by z plus 3. Then c is 3. 3 by z plus 2. So stage 1 is over. What I told, the first stage is find the partial fraction. Next stage, I have to apply the binomial series expansion. So what we seen in the, just before we seen 4 type of series. So we have to apply the series. Okay. Okay, now 1 implies z square minus 1 divided by z square plus 5z plus 6. I can write this z square minus 1 by z minus z plus 3 into z plus 2. So before we apply the partial fraction, finally I have 1 minus 8 into 1 by z plus 3 plus 3 into 1 by z plus 2. Now my case 1. What's our case 1? Modulus of z, this is my case 1. Modulus of z less than 2. Okay. So this is our condition. I need the condition modulus of something is less than 1. So here I have to make is less than 1. How do you make less than 1? Keep 2 in the denominator. Keep the 2 in the denominator. So finally we have modulus of z by 2 is less than 1. I have only one condition. Okay. Now directly write the function. What is my function f of z? So this is my f of z. Okay. This is my f of z. Okay. My f of z equal directly I can write this 1 minus 8 into 1 by z plus 3 plus 3 into 1 by z plus 2. Okay. So I have the condition z by 2 less than 1. So I can apply the condition for this term. If I take the 2 outside, I will get 1 plus z by 2. Then I can apply this condition for this term. But for this term, I need a condition. See, one clue I will give you. Suppose I have only one inequality. Okay. So the existing condition is 2 by 2 is less than 1. The similar condition for the another term also. Okay, the similar condition for this term. That means here I have z plus 3. I need the condition. Here I need the condition z by 3 less than 1. If you think that 3 by z less than 1, we cannot. That is not possible. Okay. So suppose I have only one condition for case 1 and case 3. The existing condition is z by 2 less than 1. That means numerator variable, denominator number. The similar condition exists for the second another term also. Okay. So here the term is in the term containing 3 in z. So which implies I can write directly z by 3 is less than 1. Okay. The existing condition is numerator is z, denominator 2 less than 1. Similarly for the next term, the letter is z, the number is 3. So I need the condition z by 3 less than 1. Okay. So how it is possible, sir? Very simple. From this I can multiply 2 and divided by 3. What do you get? Multiply 2 and divided by 3. I will get multiply 2 divided by 3. I will get 2 into z by 2 into 3. Okay. Which is less than multiply 2 and divided by 3. I will get 2 by 3. 2 by 3 is less than 1. 2 cancel. Finally I have modulus of z by 3 is less than 1. Very simple. Okay. So from this condition, I cannot make it 3 by z less than 1. Only possible is z by 3 less than 1. So only I told initially. So the existing condition is z by 2 less than 1. The similar condition will exist for the another term. That is modulus of z by 3 less than 1. Directly you can write it. No need this expansion in your examination. Directly you can write it. They will give the mark. Okay. So now I have two conditions. One is modulus of z by 2 less than 1. Another one is modulus of z by 3 less than 1. So for applying this condition, I have to take the 2 outside. For applying this condition, I have to take the 3 outside. This condition for so this condition for this term, this one for this term, because the term containing z and 2, I have to apply this condition. The term containing z and 3, I have to apply this condition. Okay. For applying the condition, what I told, for this one I have to apply this condition, so I have to take out 3 outside. So 1 minus 8 by 3, if I take out 3 outside, I will have 1 plus z by 3. Similarly, for this term I have to apply this condition. For applying this condition, I have to take out 3 outside. So 3 by 2, here I will get 1, here is z by 2, so I can rewrite 1 plus z by 2. So now directly I can expand, because 1 by 1 plus something, the something is less than 1. 1 by 1 plus something is less than 1. So what is your corresponding formula? 1 minus 8 by 3 into 1 minus z by 3 plus z by 3 whole square minus z by 3 whole cube plus etc. It's enough. Then plus 3 by 2 into 1 minus z by 3 plus z by 2, sorry, 1 minus z by 2 plus z by 2 whole square minus z by 2 whole cube plus etc. That's all. The case 1 is over. The case 1 is over. Now I move on to case 3 because case 1 and case 3 are similar, so only I move on to case 3. What is our case 3? Modulus of z greater than 3. I need less than 1. So I need less than symbol. From this I can easily just interchange. So 3 less than modulus of z. From this I need less than 1. So I can keep modulus of z in the left hand side, which implies 3 by z. That is modulus of 3 by z less than 1. Okay, now I have the condition 3 by z less than 1. Okay, now write the function. What's my function? My f of z is 1 minus 8 into 1 by z plus 3, then plus 3 into 1 by z plus 2. Already I told that you have only only one term. Okay, so existing condition is 3 by z less than 1. So the second condition also similar type, that is numerator number, denominator z. So this condition for the second term 1 by z plus 3, for this I need the condition which implies 2 by z less than 1. 2 by z less than, because here I have z and 2, so the same structure here, number z, so number z. So I need the condition modulus of z 2 by z less than 1. Okay, so very simple, just multiply by 2 and divide by 3. 3 cancel 2 in the numerator. Finally I have z 2 by z. So multiply 2 and divide by 3 means here I will have 2 by 3, the same number. So 2 by 3 is less than 1. Finally I have modulus of 2 by z less than 1. Okay. Now I have two conditions. One is modulus of 3 by z less than 1. The another one is modulus of 2 by z less than 1. So I have to take out z outside. That's very simple. So 1 minus, here I have to take out z outside. So finally I have 1 by 1 plus 3 by z. Here I have to take out z outside. Finally I have 1 by 1 plus 2 by z. Now I can apply the formula, because for this one I have modulus of 3 by z less than 1. For this term I have modulus of 2 by z less than 1. Just expand it. 1 minus 8 by z. This is 1 minus 3 by z plus 3 by z whole square minus 3 by z whole cube plus etc. Similarly, plus 3 by z into 1 minus 2 by z plus 2 by z whole square minus 2 by z whole cube plus etc. Okay, the case 2 also over. Next we move on to case 2. Next case 2. What's our case 2? 2 less than modulus of z less than 3. Okay. In case 1, case 2, suppose I have less than or I have greater than, I can do the problem. Here I have 2 less than symbol. Okay, but finally I have converted this is into 3 less than modulus of z. Okay. So here I have 2 less than symbols, so I have to split this. That is 2 less than modulus of z and another one modulus of z less than 3. So suppose I have 2 less than symbol in our condition, what I have to do? I have to split it. So 2 less than modulus of z less than 3. So I need less than 1. So what are the condition exist? 2 by z less than 1, z by 3 less than 1. I have 2 conditions. Okay. Now write my f of z. What's my f of z? 1 minus 8 times of 1 by z plus 2 or z plus 3? Okay. 1 minus 8 into 1 by z plus 3 plus 3 into 1 by z plus 2. Okay, this is my function. Okay. See, I have two conditions. Which condition I have to apply In which term? Okay. See, I have the condition 2 on z, which term containing z and 2. Okay, this term containing z and 2, so I have to apply this condition for this term. Similarly, in the second condition, I have the term z, I have z and 3. So this term containing z and 3, so I have to apply this condition for this one. Okay. Now observe the condition. In condition, what are the number you have, what is letter you have, the same in which term contain the same thing, which term contain same thing. You have to identify the term, and in the term you have to apply the condition. Okay. So for the second one, I have to apply this condition. From this condition, denominator I have 3, so I have to take out 3 outside. So 1 minus 8 by 3. If I take out 3 outside, I will get 1 here. So here I will get z by 3. Is it correct? Then 3 times of, here I have to take out z outside because I have the condition 2 by z. So for this I have to take out z outside. If you take out z outside, 1 plus, here you will get here you will get 1, here 2 by z. Now apply the condition. What do you get? 1 minus 8 by 3 into 1 minus z by 3 plus z by 3 whole square minus z by 3 whole cube plus etc. The second one, 1 plus 3 by z into 1 minus 2 by z plus 2 by z whole square minus 2 by z whole cube plus etc. Okay, clear? So the three conditions are over. Case 1, modulus of z less than 2. Case 2, 2 less than modulus of z less than 3. Case 3, modulus of z greater than 3. Okay. So this is the easiest problem in unit 4. Okay, this is a very easiest problem. When you observe the condition, which one in the denominator, you have to take it outside. That's all. Okay. Thank you. So now we are going to see the next problem in Laurent series expansion. Okay, next problem, expand f of z equal to 1 by z minus 1 into z minus 2 in Laurent series. Valid for the first case is modulus of z less than 1, the second one is modulus of z, second one is 1 less than modulus of z less than 2, third one is modulus of z greater than 2, fourth one is modulus of z minus 1 less than 1. Okay. As usual procedure, there are two stages. First stage is find the partial fraction. Next I have to apply the binomial series expansion. Okay. Binomial expansion. Okay, first one, f of z equal to 1 by z minus 1 into z minus 2. Okay, I can derive this as a by z minus 1 plus b by z minus 2, because degree of numerator is less than the degree of denominator, so my partial fraction is a by z minus 1 plus b by z minus 2. Okay, after this as usual procedure, but I can write directly. Okay, so that is my a value is minus 1, b value is plus 1, a value is minus 1, b value is plus 1. How is it possible? Very simple. Just take the cross multiplication in numerator. Just take LCM. What do you get? A into z minus 2 plus b into z minus 1. Denominator I have z minus 1 into z minus 2. For what value of a and b, the numerator become 1. Here I have z minus 2. So here I have z minus 1. I need plus 1. So here, because here is a bigger number, if you put minus in here, minus z plus 2 plus z minus 1, minus z plus z cancel, plus 2 minus 1 is 1. Okay. So otherwise do directly apply the partial fraction. Directly I can observe for what value of a and b. If you take LCM, for what value of a and b, I will get numerator 1. Simply a is minus 1, b is 1. Otherwise in the previous problem, so you know the partial fraction. How do you apply the partial fraction? How do you find the unknowns a and b? So you can apply the same procedure. Finally you will get a value is minus 1, b value is 1. Otherwise directly observe, directly write it. That is not a problem. They won't reduce the mark. Okay. So now I have my f of z is minus of 1 by z minus minus 1 by z minus 1. The second one is 1 by z minus 2. Okay, clear? Okay, directly I can apply case 1. What's the case 1? My case 1 is modulus of z less than 1. Directly I have modulus of z less than 1, which implies I can rewrite z by 1 less than 1. Is it correct? So what I told, the next condition also the same type. So z on 1, I have in this term I have z by 1. In this term I have z by 2. The similar condition modulus of z by 2 less than, because in this condition I have z and 2. In this condition I have z by 1. So directly I get z by 1 less than 1. For this, the same type z by 2 less than 1. Okay. And what's my f of z? F of z is minus 1 by z minus 1 plus 1 by z minus 2. Okay. So for this one, I have to take out minus outside, because z by 1 less than 1. That's nothing but if you take out 1 outside, nothing will change. But I need the expansion 1 by 1 minus something. So here z minus something is there. But originally I have to take out 1 outside. If you take out 1 outside, there is no use. But I need the condition, I need the structure 1 by 1 minus something. So what I have to do, take out minus sign outside. So finally I have plus 1 by 1 minus z. Now I can apply the condition modulus of z less than 1. Similarly, here also I have to take out 2 outside. If you take out 2 outside, I will get z by 2 minus 1. But I need 1 minus z by 2. For that, I have to take out minus 2 outside. So I will get minus 2. So if you take out minus 2 outside, here I will get plus 1. Okay. Here I will get z by minus 2. Here I will get z by minus 2. Take it out means divide. That means if you take out minus 2 outside means I have to divide minus 2 here. I have to divide minus 2 here. Here if you divide minus 2 here, minus 2 cancel, I will get plus. Here I can divide minus 2, that is z by minus 2. So this is nothing but 1 by 1 minus z minus 1 by 2 times of 1 by 1 minus z by 2. Now directly I can apply the formula. For expand this, I need the condition modulus of z less than 1. So I have the condition. So directly I can write 1 plus z square plus z cube plus etc. For next one, I have the condition modulus of z by 2 less than 1. So directly I can write it. That is 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube plus etc. Okay. Similarly, I can write case 3. What is the case 3? Modulus of z greater than 2. So which implies 2 is less than modulus of z, which implies 2 by z less than 1. Okay. In another term I have z and 1, so similar one, so 1 by z less than 1. Okay. So what's my f of z? F of z is minus 1 by z minus 1 plus 1 by z minus 2. Okay, because existing condition is z by 2 by z less than 1. Here I have z and 1, so 1 by z less than 1. The another condition, directly I can write it. Now I have to take out z outside. If you take out z outside, what do you get? 1 by z into 1 by 1 minus 1 by z. Here also I can take out z outside. I will get 1 by 1 minus 2 by z. Okay. Previous case, if you take out 2 outside, I will get z by 2 minus 1. I need 1 minus z by 2. So on I have to take out minus 2 outside. But here if you take out z outside, I have the original form 1 by 1 minus something or 1 by 1 plus something. Okay. Now directly I can apply the formula, because I have the condition modulus of 1 by z less than 1. I have the condition modulus of z by 2 less than 1. So minus 1 by z into 1 plus 1 by z plus 1 by z whole square plus 1 by z whole cube plus etc. Similarly, 1 plus 1 by z 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube plus etc. For case 1, case 3 is over. I have case 2 and case 4. Case 4 is new. So when you do the problem for case 4, so very careful. Case 2 is as usual. Okay, now I have case 2 1 less than modulus of z less than 2, similar to previous problem, just split it into 2 parts. 1 less than modulus of z less than 2. Finally I have 1 by modulus of 1 by z less than 1 modulus of z by 2 is less than 1. Okay. What's my function? My function f of z equal to minus 1 by z minus 1 plus 1 by z minus 2. In this condition I have 1 by z, that this term containing 1 z. So this condition applicable for this term. So this condition contains z and 2, this term containing z and 2. So I have to apply this condition for this one. Okay. So when you apply this condition here, I have to take out z outside. If I take out z outside, I have 1 plus 1 minus 1 by z. I have to keep minus and outside. I have to take out z outside. So finally I have 1 by 1 minus 1 by z. Here I have to 2 outside. If we take out 2 outside, I will get z by 2 minus 1. But I need 1 minus. So I have to take it out minus 2 outside. I have 1 minus z by 2. Okay. See the case 1. If I take it out minus 2 outside, here I will get plus, here I will get minus z by 2. Now apply the condition directly. Minus 1 by z into 1 plus 1 by z plus 1 by z whole square plus 1 by z whole cube plus etc. So minus 1 by 2 into 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube plus etc. Okay. So the case 3 is over. So case 4 is very important. This is new. Okay. Okay, case for modulus of z minus 1 less than 1. In previous cases, inside the modulus I have single variable, then I can do the problem. But here I have a variable and number. So here what I have to do. Okay, very simple. Make some substitution, that's all. Put z minus 1 equal to u. So which implies my condition become modulus of u is less than 1. Now inside the modulus I have only one variable. Okay, but my f of z is given function in terms of z, my condition is in terms of u. How it is possible? Okay, for that I have to convert my function in terms of u. How do you convert z into u? Very simple. From this my substitution is z minus 1 equal to u, so my z is u plus 1. Okay, so directly substitute z equal to u plus 1 here. What do you get? F of u plus 1, which is equal to 1 by, so u plus 1 minus 1 into u plus 1 minus 1, which is nothing but this partial fraction. Directly I can apply the substitution partial fraction also. So that is minus 1 by u plus 1 minus 1, then plus 1 by u plus 1 minus 2. So because already I did the partial fraction, so I can apply the function as well as in the partial fraction. So my function f of u plus 1 become 1 by u